plus 2x minus 15. So AC is negative 15, B is 2. So because AC is negative, I need a positive and a negative number. So I have 1 and 15, 3 and 5. Those are my only options. Because B is positive, that tells me the bigger number is going to be positive, so I'll throw a negative on the smaller of each pair. And then I see that negative 3 and 5 are the way to go. So we have x squared minus 3x plus 5x minus 15. So x times x minus 3 plus 5 times x minus 3 gives me x minus 3 times x plus 5. Okay, so I just want to look at the result and the polynomial we started with for a second. Notice that the reason we got x squared is because when we multiply these two, we're essentially squaring that first term. And that middle term, the reason we get x is because we're adding a constant times x and then a constant times x. So that middle term, the variable factor, the exponent's always going to be half of what the first term is, because when we do this step, we're using that factor twice. But when we do this step, we're only using that factor once. That factor in this case being x. So if I put like x squared right here, then the only thing that would change in what I get when I multiply is that this first term is going to be x to the 4th, and the second term would be 2x squared, and then the last one stays the same. You guys see how those relate? So like if I change that from x to x squared, then instead of doing x times x when I multiply the two first terms, I'm doing x squared times x squared, which gives me x to the 4th. And instead of doing negative 3 times x and x times 5, I'm doing negative 3 times x squared and x squared times 5.
Don't you have to have an x3 in the middle there somewhere?
No. Because how would we get the x to the 3rd?
Well, I understand, but I thought if there was a space between x and x, you had to. Never mind.
So we put in missing terms only for if we have a reason to. So some reasons that we have to put in missing terms are when we're doing division and sometimes when we are factoring. So if we're factoring with two terms, we put in a missing term. But those are the only times that we have to put those missing terms in. We don't want to have like extra zeros floating around like in our final answers because they don't like do anything for us quantity-wise. Does it make sense how you can get x to the 4th plus 2x squared minus 15 essentially from the same factors that give you x squared plus 2x minus 15? I mean, they're not exactly the same factors, but the process is the same.
No, I don't get that.
Yeah, where did the other x squared come from?
Okay. So
Are we just multiplying that out, or?
yeah, so if you multiply this out, you get x squared plus 2x minus 15. And the reason that this is x squared is because it's obtained by multiplying the first term in each of these. And the reason that we have just a single factor of x in the middle term is because it's obtained from multiplying a constant times x and a constant times x. And so that's why we just have one factor of x there. So if instead of what I have there if I did x squared minus 3 times x squared plus 5, now instead of getting x squared, when I multiply the first term in each of these, I get x to the 4th.
So why would you like need to multiply both by x squared?
I'm just multiplying two polynomials.
So is that like a different problem, or is it like, are you referring that problem to the one?
They're the same. They're different problems.
Mm-hmm.
I want you to see how they work exactly the same.
Oh.
They result in the same polynomial in terms of A, B, and C.
Got it.
So this middle term is going to be 2x squared because we have a constant times x squared and a constant times x squared to get it, right? And then this is still 15. So notice that this guy and this guy are essentially the same polynomial. The only thing that varies is that instead of that first term being x in the factored form, it's x squared. But in terms of like AC, the process is exactly the same. If I wanted to factor x to the 4th plus 2x squared minus 15, AC only works with coefficients, right? So this is exactly the same for both of these. Yeah? A is 1, and B is 2, and C is negative 15.
Yeah, but you have a different answer, right?
That step is exactly the same.
Right, as far as AC is exactly the same.
Correct.
But you're gonna have a different X value, aren't you?
Your final answer will be slightly different.
Right.
I'm attempting to show you guys that the process is exactly the same. So,
I feel like I'm with Mike where right up at the top there,
yes.
why don't we have the negative 3x with that group?
What do you mean?
So if we have,
What negative 3x?
so over x times x up there,
Up where?
and we get x squared, that I understand.
So can you, like, what line are you talking about?
I'm talking about
You can count. I mean,
this one.
okay. Are you saying why don't we get negative 3x?
Why isn't it included with that? Why are we skipping it and going plus 2x minus 15?
Yeah.
Because I already know that 5 minus 3 is 2. Because it's right here. Like 5x minus 3x is 2x.
Yeah, I understand. So that I can understand, but if we have those two binomials that we're multiplying,
Yeah?
it just looks like we're skipping that step and we're leaving it out.
Well, because I already knew what it was. Like, why would you write it down if you already know it's going to be a 2?
Because it helps me keep track of things.
Yeah, exactly.
I mean, if you...
Because
That's what I
lost
think it is,
like
we're
this?
missing.
If you want
You did
me,
it in your
like,
head.
no, I didn't do it in my head. I looked at this. Like, it's right there. I didn't, like, I know that that's what it is.
Oh, but what if it was a bigger number that you know, where the difference was greater?
It wouldn't matter because that step is right here.
I get
like,
how you come
there's-
up with 2x. I just
There's the negative 3x plus 5x. That's the step you're saying I'm skipping. So no matter how big the numbers were, if I did this exact problem, it would be in that step.
so basically at that step you're just foiling. I know that you don't like that.
I'm
term, but-
multiplying.
Right, but you're still doing x.
Which
x
step
times
are you
x.
talking about?
Right there with the red brackets, number 1/3. You're doing x times x is x2, a negative 3. I mean x times x is x2, x times 5 is 5x, and then you're doing negative 3x, then you're doing negative 15, which gives you the same thing.
Okay.
That-
You're just checking your answer.
So To factor x squared plus 2x minus 15, I say that AC is negative 15, that B is 2, I need a positive and a negative, the numbers are 5 and negative 3, so x squared plus 5x minus 3x minus 15, x times x plus 5 minus 3 times x plus 5 gives me x plus 5 times x minus 3. To factor x to the fourth plus 2x squared minus 15, I say AC is negative 15, B is 2, so my two numbers are 5 and negative 3. Is everybody okay with that?
Yeah, that doesn't change because the numbers are the same.
Because the coefficients are the same. So I'm going to split the middle term and say x to the fourth plus 5x squared minus 3x squared minus 15. Yep. And then I'm going to factor by grouping. I have x squared minus 3 x squared plus 5 gives me x squared plus 5 times x squared minus 3. So now you guys can do ones that have higher exponents than 2.
Yeah, you just put you're breaking the x2 out, right?
No, I'm just doing exactly the same thing I did when it was x squared as the first term. The only thing that you have to recognize is that in order to do this, the exponents have to be, well, they don't both have to be even. The first one has to be even, and the second one has to be half of the first one, which is what I was attempting to show you here, that you obtain the first term by doing this twice. There's 2 factors of the first term of each polynomial in the first term of a trinomial, and there is 1 factor of that term in the middle term. So if we had x to the third there, our middle term would have x to the third, and our first term would have x to the sixth. If we had x to the seventh as our first term in both of those binomials, we'd have x to the 7th in the middle term and x to the 14th as the first term, because the first term has 2 factors of whatever that power of x is, and the middle term has 1 factor of whatever that power of x is. Yeah? So doing algebra isn't just about like memorizing a process. You want to notice like how things work and why things are the way they are. Otherwise, you just end up messing stuff up.
If you don't have an even number in that first one, then you can't, well, not divide in half, but split it in half, right? So it's always got to be an even.
Well, if you multiply 2 binomials to get a trinomial, it always results in an even number right here because you have 2 factors of the same thing, right? Like I have 2 factors of x squared, so that's going to give me x to the 4th. If I had 2 factors of x to the 3rd, that would give me x to the 6th, right? So, and then the middle term would have 1 factor of x to the 3rd. If I had like x to the 11th here, then the first term that I would get when I multiply would have 2 factors of x to the 11th, so it would be x to the 22nd. And then the middle term would have 1 factor of x to the 11th, which is half of 22. You guys see where we're getting all
That's
this?
just in oh, when you say the middle. you're
This
talking
term.
about- Okay, that one. Yeah, gotcha.
So the only way for this to factor is if this exponent is half of that exponent, because the first term has to contain twice as many factors of whatever the variable term is in the middle. You guys seeing it?
So if that was a x4 and, well, let's say x4 and a 1, then you couldn't do anything.
Yeah, like if I said factor like x to the third plus 2x squared minus 15. Like we wouldn't be able to do it because in order to get an x to the third in that first term, like I'd have to have an x squared here and an x here, right? Like that's the only way to get x to the third in the first term. Well, but that means that when I do whatever that constant is times this, and whatever this constant is times that, like when I do the inside and outside, I don't get like terms, right? Like I'd get an x squared and an x, which means this is going to have 4 terms, not 3. So the only way that you're going to get a trinomial by multiplying 2 binomials is if these two are the same, like have the same exponent, because then when you do this like inside and outside, those are actually like terms that you can combine into a single one, so that you go from having 4 terms to 3 terms. Does that make sense? So the upshot of all of this is that if you have 3 terms, you can factor using the AC method exactly the way we did yesterday, as long as the exponent in the middle is half the exponent in the first term. So I can factor that one's lame. Oh, that's a good one. 6x to the 4th minus 116x squared. Oh, to the 3rd, sorry. Minus, keep giving me ones that give x squared. Okay, this is going to be 8 6 and 80x to the 4th. That'll do it. What should I do first? Well, yeah, but I mean, how do I factor first? So descending order, good. What's next? GCF, which in this case is 2x to the 4th. So 2x to the 4th gives me 3x to the 4th minus 58x squared minus 40x. No, not x, just 40. So far, so good?
Yes.
And now we say, okay, I want to factor this guy, which has 3 terms. So my only hope is the AC method. And I check that the exponent in the middle is half the exponent in the first term, which it is. So that means I have a chance of factoring this. My AC is negative 120, and B is negative 58. So what is this? 2 times 2 times 2 times 3 times 5. So let's practice doing the prime factorization thing for big numbers. So I know that I need a positive and a negative, and that the bigger number is going to be negative because it has to outweigh the positive when I add them together. And so we have 1 and negative 120. Is 2 a factor? 2, and if I take a 2 out of the prime factorization, I get 60. I mean, that one you could probably divide in your head, but... So negative 60. Is 3 a factor? So if I take the 3 out there, I get x times 5, which is 40. And again, if you can divide 120 by 3 in your head, there's no need to like multiply those other factors, but it's always something to fall back on. Is 4 a factor? It is, because 4 is 2 times 2, right? And 2 times 2 is in my prime factorization. So that's 4.
Stop right now, because you know that 2 and negative 60 is going to give you your negative 58.
Yeah, but then we don't get to go through the process. Well, it's not always going to be the second one. What if it was the 6th one and we didn't practice going all the way through it?
But it is the second one, right?
In this case, but it's not always. So we're like practicing a process
Sorry.
so that, you know, if it is the 23rd pair, you can get to the 23rd pair.
Yes, ma'am.
So I took a factor of 4 out, and then I multiplied 2 times 3 times 5. So that's, what, 30? Is 5 a factor? And if I take a factor of 5 out, I get what? Oh, I didn't want that to be red. Yep. What about 6? Is 6 a factor? And we take a 2 and a 3 because that's what gives us our 6. And then 5 times 2 times 2 is 20. What about 7? 8? So remember, like when you get to the bigger numbers, this is why I wanted to get to the bigger numbers. You have to look for their prime factorization. So when I say is 8 a factor, what I'm looking at in the prime factorization is if there's 3 factors of 2. If there's 3 factors of 2, then 8's a factor of this number. So 8, and we take those 3 factors out because that's 8, and then we have 15 left over. What about 9? What factors are we looking for in the prime factorization if we want to know if 9 is a factor?
3 and 3.
Yeah, we would look for 2 factors of 3, right? What about 10? I mean, we kind of know 10 is a factor because it ends in a 0, but also there is a factor of 2 and a factor of 5 in the prime factorization, which gets me a factor of 10, and what is that, 12? There's no factor of 11 there, and now we know we're done because the next number we would look for is 12, which we already have on the other side. So when these numbers are big, it can be overwhelming to try to divide like every single time. So like using that prime factorization is pretty handy, but sometimes you have to look for more than one factor to figure out. Does that make sense? Cool. So as we noticed at the very beginning, like it was this one. So we'll use that. So 2x to the 4th, and then 3x to the 4th. Actually, I want brackets. So 3x to the 4th plus 2x squared minus 60x squared minus 40. Everybody cool with that? I knew that that middle term, that those two terms are x squared terms, because remember that what you're doing is splitting up the negative 58x squared. And so if I did like 2x minus 60x, those don't add to negative 58x squared, they add to negative 58x, right? So whatever the variable factor is in that middle term has to also be the variable factor in your 2 middle terms when you split it up, so that they add up to it. And then we just factor by grouping. So x squared, 3x squared plus 2 minus 20 3x squared plus 2. So we get 2x to the 4th. Then I have a common factor of 3x squared plus 2. And then I'm left with x squared minus 20. Now, when you have higher order polynomials, one thing that you have to think about is if you can factor your factors any further. So just like when we factored out the GCF, we then looked at the polynomial in parentheses to see if we could factor it further. We'll do the same thing down here, because as soon as I have exponents, then the possibility exists that I can factor. So I want to think about if I can factor 3x squared plus 2, and if I can factor x squared minus 20. Can I factor either of those? So they have two terms, right? Which means that middle term is 0. Well, there is nothing that you can multiply to get positive 6 that adds to 0, right? And then what about the second one? Right, remember that the only binomials that factor are the difference of squares. So 20 is not a perfect square, which means even though it's a difference, that's not going to factor, because there is not a single number that you can multiply by itself to get 20. Yeah? Okay, let's do another one. Oh, here's a good one. Let's do x to the 4th minus 8x squared plus 16. So I notice that this exponent is twice this exponent, which means that I'll be able to factor this as a trinomial using my AC method. So a times c is 16, b is negative 8. Because my AC is positive, I'm going to need two numbers with the same sign. So I'm going to need a negative and a negative because they add to a negative. And I could go through and make a big list, but this one's fairly obvious. So we have x to the 4th minus 4x squared minus 4x squared plus 16. So we factor out an x squared. And then we factor out a negative 4. And we get x squared minus 4 times x squared minus 4. And then we have to ask ourselves, can I factor either of those factors? Well, in this case, they happen to be the same. So if I can factor one, I can factor the other, right? Am I going to be able to factor x squared minus 4? We can, right? Because it is a difference. So there's subtraction between the terms. And both terms are perfect squares. X squared is a perfect square and 4 is a perfect square. So if I rewrite x squared minus 4 as x squared plus 0x minus 4, then my AC is negative 4, my B is 0, and the numbers have to be 2 and negative 2. So doing it the long way, x plus 2 minus 2, x plus 2 gives me x plus 2 times x minus 2. So far, so good? So that means that in my factorization, I'm going to replace x squared minus 4 with x plus 2 times x minus 2. So x plus 2 times x minus 2 times x plus 2 times x minus 2. What's wrong with that?
Why?
Why? Because that's what x squared minus 4 is equal to. Like, this is this,
No,
and
I
this
get what
is
it
this.
I mean, you don't even need to do that because you know 4, 2, 2.
Well, not everybody knows just as well as you do, Mike.
But why do you have to write it? Okay, you have to write it twice because it's 4, right?
No, you have to write it twice because there's two factors of x squared minus 4.
Can you just put a square root on the outside of the parentheses and wouldn't that be the same?
Sure.
Huh. You know what I'm saying, right? On the second bracket.
Yeah, but you're still writing it twice. You're just writing it twice by using an exponent.
Right, but not having to write as much.
Sure.
Okay. Thanks.
So we're just simplifying that more.
Factoring it more, yes. So the way that we know that we cannot factor anymore is, for sure, is that we have what we call linear factors. So linear factors are factors that the biggest exponent on your variable is 1. Right? So notice that in x plus 2 and x minus 2, there's no x squared or x to the third or x to the fourth or anything like that. So those can never be factored anymore. So if you have a polynomial in your factorization that has an exponent, then you at least have to think about if it can be factored more. It won't necessarily be able to, like in the last example, like those two couldn't be factored anymore. But we had to think about whether or not they could, because they're not just automatically prime. Whereas once I get down to having no exponents, then those are automatically prime, because there's no way to multiply two polynomials and get rid of the x squared. Right? So anything that doesn't have an x squared in it isn't going to factor anymore. Questions? Is this boring or are you lost? Or are you comatose?
So on the online homework, there was something that was like the difference of sums.
Yes.
Is that what that is?
No, that is that. I think you're saying the difference of squares.
So the square.
Yes, the difference. Yes, so that we talked about that yesterday. That the only one that factors, the only binomial that factors, is the difference of squares. So if there's subtraction between the two terms, and I am happy. I've had rosy cheeks lately. I think I've been outside more this summer than I like last summer. At the end of the summer, I was like white as a ghost because I was just inside working all summer. But I've been out in my yard this week, so.
So this is the one we're going with now?
Yes.
Okay.
So AC is 72. Oh, wait, that's not gonna. No, anyway, okay. AC is 72. B is negative 17. I want to change it again. I won't. I'll do another one in a minute.
Kind of big eraser.
I'll do a second one. So I need two negatives. And you guys factor from here. Okay, did everybody get -8 and -9?
I just got
72 is a pretty big number.
I used to factor it out, so I did the whole list.
Good. Yeah, and you could use your prime factorization too. So then we did like x to the 8th minus 8x to the 4th minus 9x to the 4th plus 72. Okay, I'll let you guys keep going. I mean to jump the gun. Does that look about right so far?
Yeah.
So now because there's an exponent, sorry, this is a horrible 4. Because there are exponents, I have to look at these two. So that first one, is it the difference of squares? It is, right? So x to the 4th is a perfect square. When it comes to powers of x, perfect squares are just the even exponents. Because if you have like 10, or x to the 10th, that's 10 factors of x, so you can break it into x to the 5th and x to the 5th. So as long as the exponent's even, it's a perfect square. So this is going to factor into x plus 3, sorry, x squared plus 3, x squared minus 3. Now, can x to the 4th minus 8 be factored? It cannot, because 8 is not a perfect square. 4 times 4 is 16.
I was thinking 4 plus 4.
So this stays the same. But then I have to look at x squared plus 3 and x squared minus 3. Can either of those be factored?
No.
Because 3 is not a perfect square, right? And so we're done. But notice that we thought about it in every step. Like we thought about if we could factor it. So if there's exponents, you always have to ask yourself, like, is this going to factor? So here's one for you guys to try.
Is it the other one you thought of?
Yes. Dang it, anybody have their phone out? Hey, Sam,
Yes.
will you do 16 times 9 for me real quick?
16 times 9. That's 16 times 144.
That's just for 144, not 143.
I know, but I'm adding it to 1, or -1. This is squared. Wait. I should have multiplied it all out. There we go. Oh, that's good. We have 16, we end up with 16x to the 4th minus 1 times x to the 4th plus 9, yeah? Is that what everybody got?
The thing isn't on.
Oh. Sorry, I'm going to charge my pen a little bit. There we go. Okay. Is that what everybody got? I can go through it if anybody needs me to. That's not what you got? So are we all in agreement that our two numbers are 144 and -1? So if AC is -144 and B is 143, then our numbers are going to be -1 and +144. So we have 16x to the 8th plus 144x to the 4th minus x to the 4th minus 9. And so then we factor out a 16x to the 4th, and we get, whoops, it's right here.
Oh, you did around a different way.
Oh, yeah.
Okay.
So we get x to the 4th plus 9, and then take out a -1, x to the 4th plus 9. And if you switched your 144 and your -1, you're going to end up with the same answer that I did. It's just going to be like in a different order. Potentially. Yeah?
So then that first one, we can factor more.
No.
No?
Is it a difference?
That's the active of 4x4, 4x4. I guess that way.
Because it looks like we can do x squared plus 3, and then x
Okay.
squared minus 3.
So x squared plus 3 times x squared minus 3. What is 3 times -3?
-9.
In order to get a 0 in the middle, they have to have opposite signs. If they have opposite signs, then your C is going to be negative, which means if that is addition, it will never factor, because there is no way to get both the 0 in the middle and the positive constant term, because the 0 is based on them having opposite signs, which will always give you a negative. So this is the thing about the shortcut, is that the two most common mistakes, it's not that people use it incorrectly, like when it can be used. The most common mistake is that people try to use it when it doesn't actually apply, like in this case. So like if that was x to the 4th minus 9, you probably could all use the shortcut perfectly, but you have to know that you can't use it on x to the 4th plus 9. So that's kind of the danger of the shortcut, is like knowing when it actually can be used and when it can't. Because when we use shortcuts, we usually don't check to make sure it works, and that's where we get ourselves in trouble.
I guess I didn't feel like it was a shortcut. I just saw that it looked like there was more to do.
Yes.
So there isn't more to do.
But so when I say shortcut, I just mean like you probably didn't actually write like this out and say AC is 9 and B is 0 and then make a list.
Okay, yeah, that's a shortcut.
So that's all I mean. There's nothing wrong with the shortcuts. In fact, I hope that you will all use them like by the end of the semester, because it makes everything else go a lot faster. Because, like I said at the beginning of all of this, like factoring is something that's used inside other problems. Like we don't ever factor just to factor, except when we're first learning how to factor. So it's part of bigger problems. So as fast as you can get at it, the better, because you'll be doing a bunch of other stuff other than factoring as well. So this guy can't be factored anymore. But this one can, and this is where the other common mistake with this shortcut occurs, which is this. Right? We're like, oh, my AC is negative 16, so my numbers are 4 and negative 4, which is true, but just because your numbers are 4 and negative 4 doesn't mean that that's what the constant terms are, right? Because 4 times, or x times x would just give me x squared. What this is, I'm sorry, this should be x squared. This is x to the 4th minus 16, right? So when you use the shortcut, you have to be really careful that you're paying attention to like which factors are in which terms. So in order to get 16x to the 4th as my first term, this has to be 4x squared plus 1 and 4x squared minus 1. Do you guys see the difference between that and the other one that I wrote? So it's important that when you use the shortcut, you pay attention to like what your two terms are. So the constant term will factor into the constant terms in the result, and the variable term will factor into the variable term. So if I have 16x to the 4th, then all the factors that make that 16 have to be in the first term. And that all the factors that make that 1 have to be in the second term. So you just want to like make sure that your first two terms, when you multiply them, you get that first term, and your last two terms, when you multiply them, you get that last term.
Because it'll turn your signs around.
Right, because the signs are opposites, we know we'll get that 0 in the middle. But you just want to make sure not to rearrange the coefficients as you're doing the factoring. Am I done?
Yes.
Yes.
No.
Oh, because the 4 can be factored.
So 4x squared minus 1 is a difference, right? And both 4x squared and 1 are perfect squares. So this, we already decided this doesn't factor anymore. And this guy's not going to factor anymore because of that addition. And so this factors into 2x plus 1 times 2x minus 1.
Okay, so hate even numbers then, okay.
Shouldn't hate anything or anyone. The only person you're hurting is yourself when you hate others.
So that's my choice.
Math really doesn't care if you hate it or not. But you can make yourself pretty miserable hating math, especially since you have to take it.
Well, it just seems more even coefficients means you're gonna factor more than you would with odds.
Exponents?
Yes.
Even, yeah, that's true. Maybe. Let's,
Okay,
yes.
so when we're writing our answer out, why do we drop the 4x minus 1?
We don't. We just split it up into those two factors. That's what this is
right.
equal to.
Yeah.
So it's like if we did a factor tree, it would look like 16x to the 8th plus 143x to the 4th minus 9. And then that factors into x to the 4th plus 9 and 16x to the 4th minus 1. And then this one factors into 4x squared plus 1 and 4x squared minus 1. And then this factors into 2x plus 1 and 2x minus 1. And then just like we do with our numbers, like that is our prime factorization.
So is that a shortcut?
No. The only reason I could write all that is because I already knew all the answers.
Yeah. It's just, I was looking for a shortcut, so.
Okay, we're going to do one more problem before we go, because I should show you one that has more than one variable in it. It turns out that, again, these are exactly the same problem as when there's not more than one variable, because the AC method uses only coefficients. It's really versatile. We can use it when the variables change, because the only thing we're using for the AC method itself is the coefficients. So we just have to be careful that when we split the middle, that it's that we're splitting it into like terms that are the same as the term we're splitting. So if I do 3x squared minus 8y squared minus 10xy. So the key to putting this in descending order, notice that all three of these terms have degree 2. And so, like, I mean, what's descending order, right? If they all have degree 2, there's no way I can put the highest degree first.
Alphabetical order.
What we do is we put it in descending order of one of the variables. So I'm going to choose x. This term has 2 factors of x. This term has 0 factors of x. And this term has 1 factor of x. And so to write this in descending order, I'm going to rewrite it as 3x squared minus 10xy minus 8y squared. Because the way this factors is exactly the same as 3x squared minus 10x minus 8. We're just going to end up with an extra factor of y. Like in terms of factoring this as a trinomial using your AC method, the process is exactly the same as this polynomial, right? Our a is 3, our b is negative 10, our c is negative 8. So our coefficients are all the same, and the middle term, the number of factors of x is half the number of factors of x in the first term. So AC is negative 24, so I need a positive and a negative. B is negative 10. So I'm going to rush a little bit here because we're almost out of time, and I want to finish this one. So my numbers are 2 and negative 12. So again, at this point, the only thing that makes this different is you have to be careful about splitting that middle term. If the variable factors in the middle term are x, y, then when you split it, those two terms have to be like x, y terms. So it's going to be plus 2xy minus 12xy. So anytime you split that middle term, you're just splitting it into like terms, right? So that they add together to give you what you had originally. And then minus 8y squared. And then from here, we're just factoring by grouping. And like, as long as you are careful with what your common factors are, this goes pretty smoothly at this point. The key is getting it in the right order at the beginning. But then from there, like, it works exactly the same as any other trinomial that we factor. So we factor out a 3, sorry, not a 3x, just an x. And we get x plus 2y. And then subtraction between my terms, and I can factor out a 4y. Oh, this is a 3. That 3 is really messing with me for some reason. 3x, and then plus 2y. And then I have my common factors. And so I get 3x plus 2y times x minus 4y. So you guys see how that kind of relates to the trinomials we've been doing?
So in that case, do you have to put, like, could you switch up the 2xy and the 12xy, or do they have to be in the
Yeah,
same?
no, you can still switch them.
Okay.
So then if I wanted to factor, like, x to the 4th minus y to the 4th. So when you have something with two variables and it doesn't have a middle term, times x squared minus y squared. Okay, here's the big question. Are we done? We are not done because x squared minus y squared is the difference of squares, right? Which means I could do this whole process again where AC is -1 and B is 0 and I use 1 and -1. But if I use the shortcut, it goes a little faster because it's just x plus y, x minus y. And then we're done because there's no exponents. Because just like this one factored, this one's going to factor exactly the same way, but just with the exponents cut in half. Because the A and the C, or the A and the B and the C are all the same in both of those factorizations. Okay, guys, so be sure to check your answers to the review over the weekend. And email me if you have any questions at all, because we do have a test on Monday. We'll have like a half an hour to go over questions and things like that on Monday before the test. Yes. So let me give you your worksheet as well. And also, if you want to like email me a picture of your homework so that you can make sure you're doing it right, you are more than welcome to do that. I'll grade it for you.